So let's do something right. Let's start on time, yeah? I'm Adamantios Koumpis. I'm neither Peter Mutschke nor Yann Le Franc. Yann will be here with us on Friday. He had another event that he was unable to be here with us today. And Peter, I think this is this might be considered as private sensitive data, but he is corona positive, so he may be watching us from live stream, but he's not today here with us. So I'm taking Peter's and Jan's place today, and I'm sure that I will not do as good as Peter and Jan, who have been here leading the semantics group since the beginning, and but I will do my best. Some of the background that some of you may already know. You have been Stammkunden, as the Germans would say. Some others of you are newcomers. And the idea is about breaking down data silos to better enable cross-domain interdisciplinary research. So this is like a vision, like an aim, like a goal, like world peace. More specifically, one may see that a stepping stone was the report, this report Turning FAIR into Reality, which appeared in 2018, and it was a report by a special expert group from the European Commission about use of FAIR data in information infrastructures. And one may see there that same as with the Internet Protocol, that it is a minimal protocol. The idea is about having FDOs offering such a similarly minimal protocol that will serve needs of both data and services. Many of you have been already exposed to this digital objects conceptualization. It may seem very naive, or it may seem very simplistic, but it might be a good way to introduce digital objects like in a textbook. And the idea now is that digital objects, they need some type of machine actionability, which is what brings us to FAIR digital objects. And the idea is to add explicit semantics to digital objects and enable machines, whatever one may understand under machines, to interpret the digital object aspects and description. And there are several open issues. Some of them, they have been pending since the beginning. Some of them are still work in progress. Apart from an agreement on FDOs and on protocols that maintain the FDOs, there needs to be an agreement on the minimal set of mandatory metadata. There is also an agreed semantic model which is still in progress for FDOs, agreed models of combining insights of the structures of DOs and link data, and most importantly, showcases and reference implementations of FDOs. This is actually what we see as an area, a pain area, where we try to concentrate our efforts so that there will be some real-world use cases that will offer some type of validity check to FDOs. So the value will not be necessarily come from theory, but from practice. This is something that we have intensified our efforts, and this is also one part that will constitutes today's workshop. So these are the objectives of the FDO forum in general. It is a neutral place to exchange information about all relevant aspects related to FDOs. It aims to achieve a better coherence amongst initiatives working on FDOs and to finally advance the specification and application of FDOs. Now, practically, this means that we aim to bring together the FAIR guiding principles with the concept of digital objects and aspire towards a new infrastructure, which may be the Internet of FAIR data and services, and pave the way to automated data management and processing. Same as I said before, it will all depend on how reality, practice, applications will sustain this vision. And currently, FDO-SEM that organizes this workshop is only one of the 5 working groups. There are working groups on basic infrastructures, fair implementation profiles and practice, canonical workflow frameworks, and technical specifications and implementation. About the FDO-SEM objectives, and it's important to have a little look here because at the end we will ask you to be actively involved and participate. The idea is that the semantic model of FDOs to make FDOs semantically more interoperable. And there it is about three aspects: specifying a minimum set of metadata that comprise an FDO, specifying a set of unambiguous semantic predicates that make semantic descriptions of FDOs machine actionable, and also offer reference implementations and showcase based on real world use cases. So this is actually all three aspects at some point will be covered together today. The first two by Luiz, Bonino, and the last one, the reference implementations, at least a showcase of how a reference implementation might look like, by Zeyd Boukhers. And these are activities that have taken place over the previous period. Regrettably, many of them took place in hybrid form over Zoom and Google meetings. So it's nice that we are all together today here and we have the opportunity to meet face to face and also discuss and set the base and the start for new synergies. And this is the agenda. So we will have Luiz presenting the Fair Digital Objects Framework, and then Zeyd Boukhers will present a test case for applying a fast-track approach for FDOs in the health domain. And then we will have a discussion, not between me, Zeyd, and Luiz, but with your participation. So you may prepare with provocative questions, difficult questions that might also provide a fertile ground for a dialogue. This is something that we miss, all of us. And the idea, as I said before, is to broaden the base of use cases. This means that we would welcome you to come up with ideas so that we might offer stress tests for the model that we already have into real use cases, not theoretical ones. And for this, a contact person apart from the participants, Luiz and Zeyd, it's also Peter Mutschke and Yann Le Franc. So, Luiz, the floor is yours.
Thank you, Adamantios. Good afternoon, everybody. Can I switch? Can we switch to the? Okay. Okay. Good afternoon. My name is Luiz Bonino. I work for the Leiden University Medical Center and the University of Twente, and I've been involved in FAIR since the beginning, since January 2014. So it's almost 9 years in this thing. And in the last 3-4 years, I've been looking into the digital objects architecture by Bob Kahn. We are going to have his keynote later today, and trying to look what are the points in the digital object architecture that would help us to facilitate the realization of the FAIR principles in an infrastructure point of view. The internet and the web, as we have today, they are lacking some of these features that are required by the FAIR principles as a facilitator from the infrastructure point of view, and looking at the digital object architecture together with the newer technologies like a semantic web, linked data, and so forth. How do we combine them and create a basis for new classes of applications and uses that could have these features that we are going to discuss today. So I assume that you have heard or seen these things before, passing by. So we have these principles. They are generic by design, so because they are principles, they are not implementation guidelines, but because of the let's say the widespread adoption that they had, very fast and very broad, a lot of people started look at them and trying to implement or realize them. And then we have a lot of divergence, let's say, for now, but that's a normal phase. And GoFair and other initiatives are trying to pick up these different implementations or different approaches and try to converge and pick up which ones, what are the features that are positive and negative, and try to combine and get to a more solid and a well-established solution. So I'm not going to go into the details of the principles, of course, but one thing that I would like to extract from the FAIR guidelines, the FAIR Guiding Principles for Scientific Data Stewardship paper that we published in 2016, is this part, that the principles were designed with machines in mind, not because we want to eliminate the humans, of course not. This whole thing is for us, for our benefits, but the principles were defined with machines in mind because we wanted the machines to facilitate as much as possible so we can focus on the things that we are good at. So this section from the paper says that this necessitates machines to be capable of autonomously and appropriately acting when facing with the wide range of types, formats, and access mechanisms and protocols that will be encountered during their self-guided exploration of the global data ecosystem. So we are envisioning a set of, let's say, autonomous artificial agents that go around, discover things, and based on the information acquired in this discovery, they will be able to act autonomously and appropriately on our behalf. But how do we how do we realize that, right? It seems a hard problem. It is, but we have to. We can do steps towards that direction. So if you look at this part of the FAIR Principles paper, and we translate this from the point of view of these artificial agents, what do they need to answer? What kind of questions they need to answer in order for them to have this autonomous behavior? So we believe that they should answer some very simple questions, like what is that I'm dealing with? So I discovered something. What's that? How can I get more information about that? What can be done in general with that? What kind of things that can be applied to this type of thing? And what am I allowed to do, which is slightly different. So we can have something that has a lot of capabilities and properties that we can act on, but maybe I'm not allowed to do all of them, just a subset or none of them. And I need to know that before being able to interact or to reuse that thing. So then, in a very simplified way, we have a kind of steps, a kind of scenario, interaction scenario that we envision that should be supported by the FAIR digital objects. So coming back to the self-guided exploration of the digital environment, we have an artificial agent that found something that looks like an identifier. And then, okay, I found this identifier. What does it identify? Right? What's that? What these things refer to? So then, the idea of the infrastructure is that this artificial agent is able to ask the environment, the infrastructure, what does this identify, and get some information like, oh, this is the identifier of a data set of pollutant concentration in the IJssel River here in the Netherlands, or whatever other type of object that's in this particular case. And if you want to know more, the metadata record or records of this data set can be found using this identifier. So this is the identifier of the metadata record of this object, which is a data set of this specific type with these characteristics. So this is what an FDO server that hosts information about digital objects would be able to to answer once the client asks this question regarding the identifier of the object. And then this information answers some of those questions, right? So this is what I'm dealing with. I'm dealing with the identifier of a data set with these characteristics. And if I want to have more information about that, this is how I should, where I should follow in order to get more information, metadata about that object, more description about, you know, what are the things that this data set contains, who created, what's the license, and all these other types of metadata that can be assigned to this to better describe this object. So then the client could say, okay, I want to know more information. Can I have this metadata? And then sends not anymore the identifier of the object, but the identifier of the object's metadata that was provided, and then receives the metadata, like the type of the object or all the typing system information, provenance, license, access conditions, semantic model, etc., etc., etc. So then the client, based on the type, for instance, what's the type of the things, in this infrastructure, we can infer what are the things that can be done with this object. Different types of things, we can do different things with them. For instance, if you have an object that's an image, we can, for instance, reduce or extract the resolution information. If it's a photo, we can get some information about the camera that took this photo. If it's a XML data set, for instance, we can navigate the hierarchical structure of the data set and so forth, which is different from different types of objects. So the type of the object can be related to the things that are allowed or that are possible to be done with this object. And information, metadata information like license and access conditions can provide information of what am I allowed to do with them. So if I have, if I can do these kind of operations on the object or not, this is what should be present in the license and access conditions. And if I want to do something, what's I need to provide login and password, what's the access protocol to follow. Okay, and then with this information, the artificial agent can have options, or it has enough information to either identify that object is what it was looking for, and then start interacting with that directly, or say, no, I have enough information that I can conclude that this is not what I'm interested on, or I'm not allowed to use that, and so forth, which is already a progress if you take into consideration the today's state of affairs, that we have to retrieve the whole object, look inside, and then conclude whether we can or not be interested on that. So in order to define this required infrastructure and how to approach to answer those questions or to enable this kind of interactions that we just saw, we are proposing this Fair Digital Object Framework, so FDOF, as in framework, not in forum, but with some characteristics. So the basics, the first thing is that it's inspired by the digital object architecture as defined by Bob Kahn, and adopting some linked data and conceptual modeling techniques to enrich that and to facilitate in the current area that we are on how to provide more machine actionability for the whole infrastructure. Also, another characteristic is to have a clear separation between object identifier and metadata as required by some of the FAIR principles. We have a predictable identifier resolution behavior that we're going to see later. We have a mechanism to access, so based on in this predictable identifier resolution behavior, we have also a mechanism to access the metadata from the object's identifier, right? sometimes the object itself is not in a format, for instance, in an image or some an audio file, for instance. It's hard for you to embed links to metadata or metadata inside them, besides the basic ones that are provided by the file format standard. So with an FDO server, this identifier is associated with the metadata records that are describing that object. So we can have a mechanism to get this metadata. And we have some defined relations between metadata and object as required by the principle F3. We have a common machine-actionable metadata presentation format, and this is something that I use presentation, not representation, as suggested by Peter Wittenberg, to highlight the fact that internally you can have your metadata in whatever format you want, but when you are exposing this metadata in this FDOF environment, please present that in this agreed upon format to guarantee that other applications or other entities in this ecosystem will be able to interpret the metadata. If you have metadata, one metadata in CSV, another one in RDF, another one in XML, another one in a README file, it's going to be very, very hard to have applications that can interpret and can read them. So agree on a common presentation format is one step towards improvements in interoperability. And the framework includes an objects typing system that we're going to discuss a little bit further. So according to FDOF, a fed digital object is a bit sequence. So we are talking about digital things. Digital things come in a sequence of bits. That's why they are digital. But it's not any bit sequence, a bit sequence that represents some informational unit. And Eric here and Barend also coined this very interesting acronym, MAUI, minimal machine-actionable units of information. So that's exactly this concept of having something. I don't care about what kind of format for now, but that bit sequence represents something that has an informational usefulness. And this is presented according to the FAIR principles. So the point of view that we took here, it was from the FAIR principles, look at the digital object architecture, how do we set this up? So the framework comprises a set of implementation choices, of course. It's a concrete, implementable thing, so it has to have some implementation choices. Cannot be vague, otherwise it's going to be very hard, but we try to, following the internet hourglass model, we try to define as minimally as possible these implementation choices to guarantee a minimal set of interoperability and actionability in the framework, but that is still leaving a lot of freedom for implementation. And you have these choices for things like the identifier resolution behavior, metadata presentation format, metadata access mechanisms, qualified relations between the objects and their metadata. And it's based, as I said, based on the hourglass principles to set the minimal requirements. So the lower possible entry barrier for implementers and so forth. So here we are going to go through some diagrams to try to come up in a very simplified way to convey the information about how this framework looks like. At the end, I have a picture of the whole conceptual model that we have to represent those kinds of things that will seem very complex, but we have solutions for that as well. So we have this bit sequence. These bit sequences are identified by given identifiers. We have metadata records that are used to describe them, this bit sequence. We have the FDOF typing system that allows us to characterize, oh, this is of that type and so forth. And then this typing system defines some operations that are applicable and allowed to these bit sequences. So that's in a very simplistic way. So we are going to increment the complexity on this gradually. So But even in this simplified view, we have some elements that already demonstrated that we have a clear separation between the identifier, the actual object, and the metadata record, so the description of the object. And then we have the typing system that answers the question, what is that I'm dealing with? The first question that we had. And I also answer what can be done with that, with the typing system associated with the operations information. And then we have the metadata records that contain, for instance, license access rights that can answer the question, what am I allowed to do with this? So between the object and metadata, we have some defined relations as required by the principle F3 that metadata clearly and explicitly include the identifier of the data it represents. That's how it's written in the it describes. It's written in the paper. So we have this. So a metadata record is the metadata of that bit sequence, and the bit sequence has that metadata record or metadata records. And then we have some predictable resolution behavior. By default, if you just don't say anything else, we try to resolve the identifier. It resolves directly to the object. As let's say, once you get we interacted or we checked the first time the object, most of the subsequent interactions with the object you want to have directly with the object. You don't want to have the metadata record in between. So that's why the default resolution behavior is directly to the object. But if you just discover this identifier before interacting directly with the object, you want to know more information about that, and then you can request or can resolve the identifier of the object to a specific type of metadata record, which is a very minimal metadata record that contains information about this is the type, this is the link to the other metadata records, and so forth. So this is a very simple, minimalistic or minimal view of the object, but still it is a subtype, a type of metadata record. But some type that the FDO server includes and provides with a special kind of request. And then with that, we can have a mechanism to access the metadata, because if you get the identifier of anything, you request this identifier record that contains the references to all the known metadata records for that object. So in this way, you can have access to the metadata records given the identifier of the object. So this is the conceptual model. Of course, I'm not going to explain them now, but this is just to show you that there is something. We spent some time at least drawing boxes and lines and decorating randomly with some text. But and I liked I saw this, actually I changed this week, this slide with this quote: "Concepts are the glue that holds our mental world together." Right? Because try to justify why we spend a lot of time thinking about this conceptual model. Because whatever approach we have, whatever system, whatever infrastructure we have, it implies a conceptualization. It has an implicit conceptual model. But the problem of having implicit models is that different people will interpret in their own way, because they don't have all the information. They say, okay, yeah, I interpret this with my background information, my perspective, and so on. And this may lead to a lot of problems, semantic interoperability issues, incompatibility, and problems that later are very hard to track back. So we try to make this thing very explicit to try to minimize this misconceptualization. So to try to make this very explicit. Of course, nobody, or maybe just very few people should understand this. Because, you know, of course, we can never have any hope of these things being used if we require everybody to understand this. That's a no-go from the beginning. Just one question. Who, I know that there are a lot of technical people, so it's not applicable to you, the question. Who here knows how to manually trigger an HTTP a GET method? Okay, so these are the technical people. Less than half of this. For the ones that don't know how to do that, do you acknowledge that you do that hundreds, if not thousands of times per day? Do you recognize that? Or you don't even know what's an HTTP GET request, right? You do that hundreds, if not thousands per day. Every time you click in a link in a website, every time you press something in your app, this is happening behind the scenes. And this is the same, and even behind these requests, a lot of more complex things are happening behind the scenes with the DNS servers and, you know, routers around the world. We don't need to deal with that in that level of technicality all the time, because we have tools and infrastructure that hide this complexity. This is the same principle here. We have a somehow complex, but necessarily complex model that will be transparent for 99.9% of the users through protocols, through libraries, through applications, client applications, and so forth. So don't be afraid. That's the message. So for instance, we could have a very simple web form. It seems that everybody can interact with that. This is a mock-up, right? But at least is some directions for implementation. So imagine that you have a FDO server. You want to create your new FDO, right? You go to a server like this and you say, okay, what's the type of thing that I'm creating here? Is it a data set? Is it a specific type of data set? You know, you can have a lot of, so the typing system it's a little bit complex. For instance, here we have types. So the types here are applicable to both the object as an informational artifact and to the encoding format. Because if you go to the internet and the web, most of what they call types are just the serialization formats. If it's an XML, an RDF, which kind of RDF, CSV, JSON, whatever. It doesn't say anything about the content. It just say that, okay, this uses this kind of file format. That's what it says. And this is represented here as encoding type. I don't expect you to believe me that this is that I'm pointing is the encoding format. But then we have what's more relevant in a higher level of abstraction, especially for us to interact with, is that object not as a file type, but what the content of this file actually represents. And these are the object types. So we have a clear separation, and we have both. So we are not, both are important. This is the encoding format. It's very important for applications to be able to even check if they can manipulate that file or that format. But this is what really means. So is this a patient, electronic patient record? Is this image of someone in a birthday party with, celebrating with a birthday cake? So these are the same kind of things that you can represent in this type here. So then here you just select, okay, I'm creating a fair digital object of this type. Is it I want to upload my file to this server, or I just want to, this bit sequence already exists somewhere, and I just want to refer to that. So just provide the URL of that thing, the location. And then you provide the URL. If that's the case, you get some basic metadata information. that's applicable because you select here data set. The type of the object, it's also connected to a kind of minimal schemas for the metadata for that type. So then once you select here, this automatically is loaded with the minimal metadata schema for that object type. And then you start filling this, and then the tool behind the scenes is start to creating all these types of artifacts that are classified as being of those types that are defined in the conceptual model. So you don't need to understand this, you don't need to even see this, but this thing is being populated with information that you provided behind the scenes and put in the right places and responding to the right requests. So that was the idea of having this very, very simplified view of the Fed Digital Object Framework. And now we can see a concrete example of parts of this model being implemented. Thank you.
Thank you, Luiz. Let's just wait a couple of seconds until the slides are uploaded. All right, hello everyone. My name is Zeyd Boukhers. I work at Fraunhofer Institute for Applied Information Technology in Germany. I'm speaking today on behalf of my colleagues, Oya Beyan and Adamantios Koumpis, who is sitting here with us today. So in this talk, I'm going to map a real use case to what Luiz has presented, to the Fair Digital Object Framework. So I will focus here on a use case in data science, artificial intelligence, and maybe more precisely healthcare domain. So when we talk about a data science workflow, so it involves actually more than data scientists. It involves other partners and stakeholders. So, for example, if we have a data science project in the healthcare domain, so we need, or data scientists need to serve the healthcare domain, so need to serve physicians, diagnosticians, and other people who practice medicine. And depending on the domain, the challenges vary here. So we have the problem of transparency, reproducibility, the fairness toward minor groups, and interpretability. However, I believe that we all agree that in data science and artificial intelligence, more or all projects suffer from the problem of reproducibility and interpretability. Because back to the case of the healthcare domain, if you are building or developing a data science or machine learning model for healthcare domain, you need not just to give a result or an outcome to the physician, but also you need to interpret this result. And you need also that this model or this code can be, or the result actually can be reproduced by using the same code. So that's why that's our goal at NFDI for data science. NFDA for Data Science is a German project among many NFDA projects. The goal here is to, the goal of NFDI for Data Science is to support all steps of research data projects. And in the context of fair digital objects, our goal here is to make the data science workflow or data science process fair. So what do you mean, or how we are going to do this in practice? All right, so back again to the data science workflow or the artificial intelligence workflow. Actually, there is a difference between artificial intelligence and data science, but I think that's not our point today. So therefore, I'm using these terms interchangeably, and I assume that you understand this. So in a data science or machine learning workflow, there are many roles. So not only data scientists, as I said, who are involved, but we have data stewards, we have stakeholders who define the goals of this data science project, and so on. I mean, even for small projects, let's say for a master or bachelor thesis project, where we have only one person doing everything, we have different roles. We have the development of the data science model or the machine learning model. We have the collection of the data set. We have the pre-processing. We have the data integration until the result. So this brings us to the fact that we don't have only one information or only one digital object in this process. We have many. So we have a data set, right? That's what we need to work on. We have the tools that we are going to develop or we are going to use in order to reach our final goal. We have the code that we are going to develop and build in order to reach our goal. And we have the result that we are aiming to reach at the end. However, all these objects are located in their own environments, right? So a data set can be located in data repository. The code, the same thing. We have tools. If we talk here about containers, they are also located in their own environments. The publication or the results are actually published in publication and also located independently then the other objects and so on. So that's why our goal at NFDI is to, as I said, make the whole process here fair. So actually here, if we consider each of these elements of the data science workflow as a digital object, as I said, each of one is located in its location, and our goal here is to register them in a registry and build links among those elements or among those digital objects so that we ensure that the entire workflow, the entire process here is fair. And here I will give a concrete example about one of our work. Here we have a paper about distributed skin lesion analysis. And for this, we use distributed analytics. So here we have more than one data center. And for privacy reason, we cannot collect the data at one location and process this data at once and get a result from it. So we have more than one location. In this diagram, I have only two, but in reality, we have more than two locations. So here we have the Uniclinicum Aachen and Uniclinicum Cologne. And we have a developed data science model or machine learning model, which is deployed, and we have an image container that will visit each of these data centers or these stations and run at each of these stations on the data located there. So I'm trying to use the laser where it doesn't work. So first, it's for example here it visits the data center at Cologne. It runs there, it gets the result, and then it goes to the second data center, which is located in Aachen, and does the same thing. And if we have more data stations here, it will also visit all of them until collecting the results from all of them. And this runs in an incremental way. So this is incremental learning. So more specifically, I will just repeat myself here, but maybe in more detailed steps. So first, the code is developed, so statistical and machine learning models. And then a container is created out of it. Then this container is sent to the first data source. it will run there, and then visit the second one, run there, the third, the fourth, until the last one, and then we explore the result, write a paper, submit the paper, and have a publication at the end. So now I will use here, I mean, the same example, but in a more concrete way. So what we have here, I mean, I will identify digital objects. Of course, if you want, you can have more digital objects in a hierarchical way, but here I'm just picking here the main ones. So we have the source code, and as Luiz said, what we need for digital objects, I mean, the most important thing that we need that the digital object is fair, is the identifier. We have an executable container and its identifier. We have data sources and we have publications. So maybe here these identifiers are not PIDs, are not persistent identifiers, but for the sake of simplicity, we can consider them here as identifiers that can work for or that can satisfy the FAIR principles. So this graph here, or this image here, it just explains what I was saying. We have the source code. The source code we will create an executable container out of it. The container will visit the first station, run on the first station, and then go back to the second one, run on the data there, and then come back to the main station, and then we have a publication out of it. So we have a concrete implementation for this, which is called PADMI, Platform for Analytics and Distributed Machine Learning for Enterprises. That's the code bar here, which takes you to the website of this implementation. It's an implementation of personal health train, which is also called data visitation. So where you have the data located at its location, and then you have machine learning model visiting each of these stations and run over there. Actually, this solution doesn't solve only the problem of fair digital fairness, let's say, but for many other purposes like privacy and so on. All right, so as I said, so here we have locations where our objects are living. So here we have the GitLab repository where we have our code and or Docker container in this case, and here we have Harbor, which is an HTTP tool that can help pull and push image containers. So here we have the framework that that Luiz presented. I think it's scary a little bit, yeah, but don't worry. That's the only slide where I have this this conceptual model. So here we tried in our implementation to follow this conceptual model that Luiz presented and yeah, explained. So here I'm going to continue, but using the simplified one. I'm not going to use that one, which is yeah, maybe a little bit complicated, and for the sake of time, it's difficult to explain everything there. Even though I will focus only on this part, otherwise I don't have enough space here to present all digital objects, so I will focus only on the source code and the executable container for the sake of simplicity, as said before. So here I'm just using the same conceptual model, the simple version of the conceptual model that Luiz used in his slides, and map it to our use case. So here we have the fair digital object, which is in our case the executable container, which has metadata, right? And the metadata is our fair metadata record, and our executable container or fair digital object, so here I'm calling it fair information object, but I mean the same thing, is characterized by fair characterization, which is associated with the source code. So source code here is another digital object. And we have here information object type, which is, we know that this is an executable container. That's very important, as Luiz said, to know what we are dealing with, what this object represents. And we have here materialized by executable container image. Of course, I can expand this even between the executable container and the metadata. I can expand this even larger than what I'm presenting. But yeah, in that case, it will be just complicated. But actually here, it's the same principle will be applied to everything. Even if we have a bigger image here, or if we include other objects or other elements here, it will have the same, or the same principles actually will be applied. So now I will even zoom in even more and take this part in order to have an RDF modeling for it. So here, this is an RDF modeling or representation. So we have the executable container here, and the executable container, let's see, so that's what I'm talking about. And it has metadata, so it can take us to the metadata. And from the metadata, it also tells me that this is a metadata of something, of a digital object, which is here our executable container. So it takes me back to our executable container. The same for the image, the container image, so materialized by, and we have here the identifier of our container image, which will take me here. And here we have the same thing. Materializes what? It materializes our executable container. And of course, here we have some other record, or record card. Let's like Luiz used. I don't know whether he used today. I was not. Maybe I didn't hear the term today, but I heard it before. That you don't have here. For example, here we have creator and license. This is in addition to the metadata. We have something that is associated to our executable container. The same thing for metadata and for the executable container image. Yeah, actually, that's everything. Thank you very much for your attention.
So the idea is now that you may come up with your questions, which we will try to do our best to provide convincing answers. So I will facilitate the microphone, yeah?
Thank you very much for very clear presentations. But I do have one additional question for Luiz, and also actually for the second speaker. So you could argue that as long as the metadata contains all information about the object, that the digital object itself is actually metadata. And I also noticed in the second presentation, to one of your last slides, you actually had a lot of information like license and creator at the object level, which also are duplicated or supposed to be duplicated in the metadata. So why do we actually need those two levels? So give a clear motivation of why we cannot have an identifier resolving to simply the metadata that contains everything, including the option to present itself in many different ways.
Nice question. Nice question. So because first it depends on what we are calling the digital object, at least at the target. So the distinction between something and the metadata only makes sense when you are looking at this tuple, right? It's always a relative relationship. So if you have metadata about something, that something may be metadata about something else, maybe it's metadata something else. So it only makes sense, this distinction between what's the, for instance, when we look at the FAIR Principles paper, we just, to simplify, we say metadata and data, but data here is any kind of digital object. So we have to define first what we are targeting as the object. So here, in the framework, the object is the bit sequence represented or exposed to the world using that model. So there are some properties that are inherent to the object itself, right? For instance, we have the license. The license applies. So all these properties actually apply to the object. All these properties that we are discussing there, but they are captured and represented in a metadata record. For instance, if you have a binary code, that's the object that we are targeting, we don't have space there to put metadata. So that's why we need a second independent artifact, also because this independent artifact has its own life cycle. So the metadata record has a life cycle that's different from the object. We can have multiple metadata records pointing to the same object. They are located, can be located completely independently. Before, we didn't have this flexibility, right? Images, they have a header in the file, in the binary part of the bit sequence. We have some space in the header of the file that has some structure to put some things that are metadata information about that object. So that's why we have this distinction. And when you are represented that in terms of a metadata record, we make explicit that, you know, these are the properties of this object, but this thing is brought to you in a metadata record. That's the point.
Yeah, maybe I will also add something to what Luiz said. So actually, what Luiz and I have presented is a conceptual model and an implementation of it, right? And it can be always improved. That's the point. So and what you raise actually is true, but maybe from your perspective or the perspective of the domain you are representing. But if I pick, for example, scholarly data analysis, I would say we will have a different problem, because what we want that these FAIR digital objects to be machine actionable, right? So do I need always to visit the metadata to do simple things or not? So maybe I need to have some simple attributes that, for example, the license that tells me, okay, am I allowed to use this digital object or not? So without even having a look to the metadata, right? Because metadata in some cases can be very, very detailed, and we have a lot of description that we don't need at the first phase to understand what we want to do with the object. And what Luiz presented in one of the first slides is what this digital object represent. So that's very important. And if I need to go to the metadata to understand what's this digital object, I'm not talking here when I say I'm not talking as a human being, I'm talking as a machine. So if the machine needs to go to the metadata to understand, that's a step that maybe we don't need. Yeah, I hope I answered your question.
And by the way, metadata record is a specific type of digital object, right?
I have a comment to the question, and I have a comment to the question, and then another question. So the comment is that actually you have three levels. You have the digital object, the materialization of the digital object, and then the metadata. And then when you talk about licenses, for instance, you can have different licenses for different materializations. So I noticed that you have an identifier for the digital object and for the metadata, but not for the materialization. Do you need it? And the other question, also the real question that is kind of the comment to the question. So the next question would be, can we have fairly detailed objects without linked data? Because what I saw in the model, what I saw in the example is link open data.
Can I have the slide, the second slide deck back, please? So the first one, we do have identifier for these three things, right? Because the information, we have two generalization sets in the model. So at the end, we have to go through the model. There is no escape. Yeah, so we have two generalization sets here. So we have this abstract class, which is fair digital object. So this is, we cannot have a direct instantiation here. We have one that it's a separation between a fair ground object, that's the actual focal point in that level that we're talking about, and its metadata. This is just a modeling trick to avoid, because a fair ground object, when you talk about that, it has to have a metadata according to the FAIR principles. So the cardinality here is at least one. But if that thing, but we don't want, we didn't want to have infinite recursive loop that a fair metadata record is a fair digital object, and then it has to have a metadata that has to have a metadata forever. So then we had here a metadata as a special type of informational object that special type doesn't need to have metadata. It can have the metadata, the first metadata level should have, but it doesn't need to have. So this is one thing. Then we have this generalization set here. A fair digital object can be classified in either the information object or the media object. That's the materialization object. So and because they inherited the properties of this abstract class, and this abstract class says that it has to have at least one, not any identifier, but a global, unique, persistent, and resolvable identifier. So it's a specific constraint on the identifier that has to be assigned to any object, either information or media object. Right? Clear that part? And then the other part was?
No, that is the first part.
Yeah. So the second one?
Can you have fair digital objects without link open data?
Oh, okay, yeah. Depend on how you capitalize the fair digital object. If you have fair with capital D, with capital O, and according to this framework, the way that you represent it, so here, again, as I said before, these are implementation choices. In the framework, we took the choice to represent as metadata, as the metadata presentation format linked data. So how your object is, the framework doesn't mind. It can be whatever. But the metadata format for that, we ask to be linked data because of the support for semantic annotation and so forth. Just by being linked data doesn't bring much benefit if you don't have, well constructed and semantically rich linked data. But when you have that, the linked data is just a tool that facilitates the provisioning of the semantic annotation that we need to refer back to the model. That's the only thing.
So whenever there is a semi-technical or technical presentation, there is a guy who asks about scalability. So today it's me. And I have a question about the fair digital object server, I guess, because you talked about, let's say, one instance, but we have different use cases, then we have several servers. And are there already any discussions about how these servers should exchange information? Is it like the DNS? Or we end up building data repositories that are kind of the islands and then synchronize from time to time. So how would it work in reality?
Very nice. So as you can expect, I'm from my background is technical. So that's my focus, and that's why I like these kind of questions. So this framework, besides the nice work that they have done with real tools, real stuff, but this whole thing is slideware today. So that FDO server is a mock-up of an interface, a possible interface for something that can facilitate that. What they did, they didn't have that. So what they did is that they created all these artifacts by hand. So then we don't have scalability problem because the human bottleneck is the constraint. But the idea here is to reuse as much as possible the existing infrastructure. Though the FDO server only answers to these very simple requests. Do I get the object? Do I get the identifier record? That's it. So it's a very simple registry that you link to something that exists on the web, some bit sequence, and you provide this information, the minimum information that's required for the identifier record. You can even have objects that already have their metadata record somewhere else, and we have been working the last 6 years for a metadata record repository that complies with the FAIR principles, the federal point, but this is something else. You can just, in the FDO server, just links that, and then you resolve. So some talks that I had a few years ago with Bobby Quick, that's in the other session, that was one of the lead people in the Quadra, I think that's Quadra, the tool that implements the digital object architecture. That thing could be just extended for the types of, to automatically fill in these types here. And that thing, they already demonstrate it exists and already demonstrate that it's deployable, it scales at a certain degree and so forth. So we want to reuse these kind of things. As Byron said, we're just too poor and too lazy to invent our own stuff. I don't know the sequence.
Okay, I have several questions, but I'll try to. First of all, you said for the capital FDOF, it's true that we need for metadata linked data. So it seems that for other fair digital objects implementations, it might not be needed. For example, signposting. Yeah, is that a way to approach this? There were a lot of discussions. I would like to know your opinion on that. Second is the typing system. Is that already in place? So I think it is discussed there also. I'm not sure in the other room. How far is that? And is there already the metadata scheme for each different types in place, or is this still work in progress? Basta.
I have no memory, so it's like a golden fish. You have to be one at a time. So let's start from the last that I remember, which I already forgot. So the typing system. So we have the framework here, the placeholders. Now, one of the things that the things that are being presented, I think that is in this session. I'm not sure, but for sure there is a session during these days that talks about this typing, type registries and so on. This is something that has been worked out in RDA and other venues for a long time, for many years. There are type registries around. There are type models as ontologies. There are all these kind of things. The idea, again, to reuse. How do we map the typing system here, the characterization part here, with this type registries, with this type ontologies and so forth, in such a way, and we just connect. And then for the user, it's just an option box that the person just selects what type they want to classify their own stuff, right? That's one thing. Then we need, because of these consequences of the typing systems with the operation types, with the metadata schemas, we have to enrich the existing type registries and type ontologies and models with this connection. I'm not sure if these connections exist today, right? Regarding the metadata schemas, this is one of the things that we have been discussing in Go Fair from the beginning, is one of the convergence activities. It's not up to me, definitely not, to decide what's the metadata schema for X type of object. For instance, in the Fair is Fair project, there was a task, I was part of that, where we try to agree with the community of ontology engineers, of semantic web people and so on, what will be the minimal metadata schema for a semantic artifact. And then if a community agrees on that and endorses that, then this can be published as the agreed upon metadata schema for that type of object. And then this is the infrastructure points to that and then populates the schema. So that's how we envision this existing. This is just the base works to enable the connection of all these kind of things. Which was? Which was? Oh, yeah. Yeah, so, sorry. It's possible. Yeah, it's possible. We already have in the Apple for Apples stuff, and Stian, I'm going to pass the microphone to him. It's possible to have that. We just have to decide. So I opt to first do this purely linked data, because I think that was more expressive, more flexible, and so forth. But that was one choice. If everybody agrees that, you know, maybe that's too much, signpost is the best solution, and so on, as long as the behavior keeps the same and you can point to the same stuff, I really not big attached to that.
Hi, I'm Stian. I'm involved with the fair signposting things, and also Herbert's in the other room. We can ask him later as well. I'm very keen on this because it's coming from two different directions, right? It's coming from what is already established. We know how linked data works and so on. We have all the tools, but yeah, it could get a bit more complicated than maybe sometimes it needs to be, and that's where I think the fair signposting can come in as a pointer to what is actually there. Because if you're just some agent crawling around, how do you know that you even reached a fair digital object, right? And that's where the fair signposting can say, hey, I'm this type, I have metadata over there, it's of this type, maybe it's linked data, maybe it's some data site schema, maybe it's some weird thing you made in an Excel spreadsheet. You can have all of those, right? It can be as fair as you want to be, right? And I think it's just like a leap. It's not sufficient alone, but it could be useful for many purposes. And then to be rich and to have expressivity, then you need something like linked data, because you need to define the terms you're going to use. You need to have some common way to express things to be special and general at the same time. So I think there's room for both.
Hi, I'm Mark Walton from IOTICS. What about the F part of FAIR? You're not talking much about findability with all this. How do you imagine that you can find something if it's in Leiden or Cambridge or Sydney, Australia? How do you imagine that working?
So we have four Fs, right? So the first one is covered. We have identifiers. That's covered. Global unique persistent identifiers for both the data metadata and the digital objects in general. So that F1 is covered. F2 says that data should be described with rich metadata. So the requirement that any digital object has should have its metadata with at least a minimal number of properties that are relevant for that type of object covers F2. F3 is covered by the explicit relation between the data and the metadata, the object and the metadata. So then we go to but these three principles, they just make these things potentially findable, right? If I have something with a very nice metadata, very nice identifiers to all of them, but I put those things in a USB stick in my pocket, nobody's going to find. So then we get to the crucial part, which is F4, that the metadata and or the data and or the digital object should be registered, indexed in a searchable resource. So we need this kind of things, right? The idea is that the FDO servers can be connected directly to search engines that will, every time you have a new object register in the FDO server or an update on that object, the search engine is triggered to reindex or to index the metadata of that object or the object if that's desirable and allowed. Google, well, we can never say that if Google, because it's a private company, they do whatever it's aligned with their business model. They are extremely high, sophisticated semantic engine, not visible to us, but behind the scenes they have very sophisticated semantic models and so on. And that's why they push a very simplified methods for us to annotate the pages, because then all these sophisticated semantic connections, only they have access to. So no other search engine can have access. So in this way, they can index, they can match this to their semantic model, but other search engines can make use of the richer semantics of all these descriptions, and maybe not the same performance, because you have to have enormous amount of data centers, but at least the level of sophistication and precision on the search can be improved based on the richness of the metadata information here. Tobias.
Thanks. Yeah, so this is super nice, super simple, and also very general, but I keep wondering, why is it not made yet a bit more general by dropping the digital aspect? Not by saying not covering digital things, but why only digital? As far as I see, this with minor modifications will also work for things in general. So maybe a more general question, I'm asking myself, why are we here at the FAIR Digital Object Conference and not just at the FAIR Object Conference? I feel that would be a kind of a minor thing to change conceptually, and it would kind of make everything vastly more powerful. What's that?
I like that a lot. And I'm already trying to figure out what's the tiny modification that you can have here. Because I think that the information object has to be digital anyway, because you need to have some kind of intermediary, let's say, a digital shadow of whatever physical thing that we want to represent as a placeholder. Maybe the only thing that we need to do is to relax the materialized by a fair media object here that's at least one. So we can have an abstract or a more general class here of fair objects that can be digital or physical, and then we have to have at least one for this general, but not necessarily one digital, and then this could cover that.
Access could be come to the museum.
Yeah, call someone, and then book a meeting. You have a, yeah.
Thank you. Most parts of my questions have already been killed, especially the finability. And as I'm not a tech person, but coming from the PID communities, maybe I have a question on persistence. When I understand it correctly, the advantage of the FDO in comparison to a PID concept is that you enter the object directly, but you also have a metadata record that is permanent, right? So you have the core metadata that is permanent and extra metadata that is maybe somewhere else, so at least connected to the object or to the FDO. But then, I mean, I see the advantage of entering the object directly, but if you have core metadata that is permanent or persistent, you can also, you have the same in the PID infrastructure. You have core metadata and you can assign object information, extra metadata that lies somewhere else. And so where's the real difference?
Great, thanks. So few notes here first. When you talk persistent, that's one of, actually that's the only thing that I'm proud of having contributed with to the FAIR principles, is with it's not there instead of what's there. So before there was something that they should be eternally persistent and so forth. And they say, no, we can never guarantee that. There is nothing that we can guarantee that will be eternal, right? It's pointless to have that in the principles because it's unverifiable. So then everybody agreed to remove that. So when you talk about persistent here, is the FAIR principles and the framework do not dictate for how long. Persistence is a social commitment between whoever is provided the identifier that commits to maintain the resolution of the identifier to the target object for a given amount of time. Right? That's what you expect as persistence for identifiers. The problem that we have today that's hard to verify the principle, this persistence part of F1, is that very rarely we have the persistence policies of the identifier identification systems explicit. So for instance, when we are using DOI or the handle system and so on, we expect we have an implicit expectation, but it's not often that people actually know for how long. And different types of uses require different levels of persistency. So Naturalis, a natural history museum, may need a very long-term persistence for their identifiers because things are there for centuries and so forth. If I'm minting identifiers for a concert that's going to happen in 1 month, I may not need these identifiers to persist way further than this next month. So the persistence for me could be way shorter than that need. So that's just a clarification. The difference between this, at least some of implementations of the systems that we see, is that we don't have, or at least across different identification systems, we have a hard time in guaranteeing a predictable identifier resolution behavior. Sometimes you get an identifier and you resolve to this metadata, sometimes to the core metadata, sometimes to the user-provided metadata, sometimes to the object, and sometimes to a landing page that's only really useful for humans. For machines, it's a nightmare because the machine will never be able to find the route to the actual object. So here, the only difference, and that's why we hope to reuse every existing identification system, we are not proposing any new identification system, is just to fix the default resolution behavior to return to the target object, or if you ask with some specific parameters, the core metadata record, or we call here the identifier record, or where you can get a list to the metadata, other metadata records that are available. That's the only difference. Yeah.
Thank you. My question is about the implementation of the model. So this could be implemented as in the objects are built on the fly, or they are stored in, you know, like whatever storage, and they sent to the user once they request it. But this sort of begs the question of storage versus process or processing, and in a way would be almost exactly the same as if you ask the user to just send a query directly in a model similar to maybe GraphQL. So what do you think? Would that be implementable?
Yeah, so it can be on the fly as long as the properties and the relations that you want to inform are stored somewhere. So the system cannot just, you know, guess what you know, the type is and what, you know, all the provenance and everything. So this information has to be somewhere. Someone has to be to have provided, or some of information. And this is something that we have been trying to you know, promote as much as for the last years, is that a lot of the metadata information should be automatically provided by the systems that are creating these things, you know, verification of the objects and so forth. But some of the things can only be provided by humans. So as long as these things exist somewhere, the representation of the metadata record or the information or the identifier record can be created on the fly, and then we have to balance between regarding performance. If this on-the-fly processing is too expensive and we expect a lot of requests, then it's better to do this before and then just serve the already created representation. If we don't expect much and you have a high performance system, you can do most of these things on the fly. So depend on the situation. So what we expect to do for the FDO server is more or less the same thing that we did with the Federa point, that we have a specification. This is the external behaviors, the minimal external behaviors that you expect from any tool that would like to behave as that thing. And then people can implement it on the fly or pre-created approaches, whatever, as long as the response to the identifier resolution behavior presents the metadata in the specified format and so forth. So that's the only thing. And then we want to have a reference implementation, but more importantly, the specification so everybody else can implement, even embedding in their tools. One of the things that I would like to do is to create a plugin, for instance, for Apache web server, because, you know, a lot of people use that to put things on the web. If you have a plugin that we can create these connections between the files that are there and metadata records, information identifier records, we can use an Apache web server as an FDO server.
Yeah, I think we got to. I better hurry. Huh? Luiz, you know that in Go Fair there was a spin out of this idea of a fair implementation profile, and that's just a list, a machine actionable list of all the implementation choices associated with fair data or metadata. So the question would be, given that the FIP currently can be given unique identifiers, is it productive? Is it useful to have that identifier in the FDOF? So, say, for example, as part of the ID record. So this would be a description, then, right, of all the implementation choices associated with a particular digital object.
I think that it is useful and possible, definitely possible, and moreover, the specification of the FDOF, because it includes a set of implementation choices, arbitrary implementation choices. These choices could be, we could have a FIP for FDOF as part of the specifications, right? besides the model, and then the model is pointed from the FIP, because that's the model that's adopted for that, and so forth. So. For fair lower letters digital objects, definitely, yeah. So we are going to see throughout this weekend many different implementations. So I think that it's 1 minute past the time. So.
So we're sitting here, everyone who I understand have quite a good understanding of the semantics and these little peculiarities that can come up. So we're kind of quite experts already, and it's telling us, yeah, we could do it in a certain way. However, on the other side, we have people talking a bit more conceptual about fair digital objects. How do we convince them? We have already done it. We have an implementation. We cannot give this diagram, right? We need a more digestible documentation, right? And they have produced lots of documents, which you can read them. You're not necessarily any wiser, but at least there is something that you can go through bit by bit. So I think we need to move into that stage as well to make sure we don't lose the train.
Absolutely. So two things. Here I tried, since I think that 2020, I guess, that I created this page, and I kind of a brain dump. I'm putting there as frequent as I can the ideas around the framework. On purpose, the model is not there yet because we are working on finalizing that. So we are working on a paper about the conceptual model. We want to have as quick as possible that in a preprint, so we can also publish the in this page the model and explain the model, given examples. So and then to answer, this is the part of your comment about the specifications, about how to convince them. I want to adopt the spirit of George Strom that's probably sitting there. You don't tell anybody else what to do. You do yourself and show how it works, and if people think that it works well enough, they can reuse. So I don't have any authority to force anybody to do that. I can present the arguments why we believe that that's a reasonable way to do that and what are the benefits. But then if someone says, okay, we have this other approach with these other benefits, and if everybody agrees that those other benefits are more important, we just adopt something else. So no personal attachment to anything.
I have a question, but not to Luiz, to you, to all of us, to the audience, including you, Luiz and Zeyd. But before, because I'm concerned about counting the conditional probability, how many of you would identify yourselves as coming from industry or representing industry? So if you could raise your hands. So it's very few. Okay, so then it might not make sense to count any conditional probability on this. So the question is, if you would listen from some colleague or relative of yours about a startup that aims to revolutionize the field with something called fair data, digital objects, FDOs. Okay, so you might read about it in a blog, or same like before 15 years about Bitcoin. How many of you would dare to risk and invest some money? It could be 200 euros or it could be 2,000 euros, so it doesn't need to be with 5 digits. So how many of you would care to invest on something like this? So it's only you and me, and so there are more hands rising. So, okay. So we had in mind to put some Slido questions of that nature, but it was too complicated. So, Luiz, I think that yeah, and I think that same no one might be from the people who attended the Sermon on the Mount may have been having faith that there was something bigger there. But as Peter Mutschke's slides mentioned, we are open. We would like to hear from you, and that we would like to welcome your participation. And